Welcome to lesson 10.8. Quick recap, in 10.7, you learned how to find angle measures and arc measures when two lines are intersecting inside the circle, two lines intersect on the circle, or two lines are intersecting outside of the circle. Okay. Now, instead of finding angle measures and arc measures, we're still looking at those intersections, but now we're going to find the length of the segments that are created by the intersection, right? So when these two lines are intersecting, you have this segment here, this segment here, this segment here, and this segment here. So 4 segments are created, and we can find the length of those segments. Same here, if we have two secants that are intersecting outside the circle, of course, you create a segment here, here, and here. Another 4 segments. We can find out the exact lengths of those segments. Now we have a tangent line and a secant line intersecting outside of the circle. We have 1, 2, 3 segments, and we're going to find the exact lengths of those segments. Let's get into the formulas. So when there's an intersection inside of the circle, you're going to be able to find the segment lengths by multiplying segment A times segment B, and that's going to be equivalent to segment C times segment D. Okay, so we're taking 2 segments from the same line. Okay, I'm going to just to color match, we have C times D is the red line. Okay. Now, when there's an intersection outside of the circle, so we have our secant line. You're going to do A times A plus B will be equivalent to, you can guess it, C times C plus D. All right. Now, intersection outside of the circle, but this time it's a tangent line and a secant line. How can we find those segment lengths? What we're going to do is you're going to square the tangent line. Sorry. I'm trying to draw the line and it won't connect. You're going to square the tangent line. A squared will be equivalent to the secant line, a segment of the secant line times both of those segments added together on the secant line. Okay, now that you know the relationships, let's see if we can somehow memorize and understand these relationships. So as usual, I will be doing even, and then you can try the odd problems on your own. Let's read directions first. Find each value or measure. Assume all segments that appear to be tangent are tangent. Great. Find BD. So this length here is what we're looking for. What is the length of this line? Well, in this case, we have an intersection inside the circle. So we know that what's going to happen there is we have to multiply the 2 segments on one line, and that's going to be equal to the 2 segments on the other line multiplied. Work that out there, and you get 36 equals 20x minus 4, because you have to distribute that 4 in, right? Adding 4 to both sides, you'll get that 40 is equal to 20x, and then dividing both sides by 20, x will give you 2. Number 4. Again, intersection is happening inside the circle, so we are multiplying the segments on one line and equating them to the segments on the other line. So that will be 2x, excuse me, 2x minus 5 is going to be multiplied with 18. And it's going to equal 14 times 2x plus 1. Okay. So again, one side of the equation comes from one line segment. One line broken into two segments, right? And the other side of the equation comes from the other line. Go ahead and do the algebra on your own there. Pause the video to give it some time. Oh, I'm sorry. Wow. We didn't even finish number 2. After you solve for x, you're going to need to actually find the length of BD, right? So you need to plug x back in to BD. I'm going to plug it here. I'm so sorry. 5 times 2 minus 1 equals 10 minus 1 is 9. And then you would have to add that to the 4 to get 13, right? Because 4 is also a part of that segment. That line. Okay, so BD is 13. Apologies. Well, luckily it's a video, so, you can stop and pause and go back as you need to. Okay. Working too fast. We're finding TQ. So now that we've equated that, you should get that x is equal to 13. And then now that you know x, you need to plug that back in to find TQ. So TQ is only this segment here, so we only need to substitute that into 2x plus 1. And 26 plus 1 is 27. So TQ is 27. Number 6. This time the intersection is outside of the circle. So it's a little bit different, right? We have this intersection outside the circle and we have 2 secants. Okay, so if you remember before, what you're going to have to do is on the first line, let's say JKL, line JKL here. I'm going to take that outside segment and distribute it into the 2 segments being added together. So it's 10 times 10 plus 42. And then on the other segment, it is 13 times 13 plus x. And then just keep in mind we are looking for NL here. So once we figure out what x is, this is the length we're looking for. Okay? So distribute the 10 in, distribute the 13 in. You're going to get that x is 27. Once you get the x is 27, NL would equal x plus 13. So you need to do 27 plus 13, giving you that NL is 40. So again, the key here is in order to set up the equation when the intersection is happening outside the circle, you take this small piece and multiply it by the entire line added together, right? So you have to add together to get the entire line. And then you take this small piece and multiply it by the entire line. Okay, so that's very important. Yes, the algebra is important too. You need to know how to solve for x and substitute it back in, but you really, really, really are learning how to set up the problems, right? How to actually find these lengths. Okay. Next problem, number 8, we have another set of another set of secant lines. So similarly, we are going to do this segment multiplied by the entire line And we're going to equal that to this segment multiplied by the entire line. So I'm going to write out exactly what I said. We're doing 12 times 12 plus x plus 8. And we're going to equal that to 15 times 15 plus x minus 1. Go ahead and perform the algebra on your own. You're going to get that x is equal to 10. We are trying to find yz, which is this portion here. So I only need to substitute into this expression. So yz would equal x minus 1. So that's 10 minus 1, which is 9. Number 10. With number 10, again, we have the intersection outside of the circle, but this time we have a tangent line and a secant line. So, if you remember from earlier, what we're going to do is we're going to square this line and equal it to this segment times the entire line. So with secant lines, you're always doing the smaller segment multiplied by the entire line. I'm sorry, not the smaller segment, because it depends, right? The circle could be small. The outside segment multiplied by the entire line. So again, square this, equal it to this times this. Doing exactly what I just said there, 16 squared is equal to 8 times 8 plus 5x minus 1. So we are doing 16 squared is going to give you 256. Distributing that 8 times 8. Well, you could do the 8 minus 1 first. Let's simplify this. 8 minus 1 is just 7. And so therefore 8 times 7 would give you 56. And then 8 times 5x is 40x. Solve that two-step equation and you'll get that x is equal to 5. Now that you know what x is, we are trying to find Pn, which is this segment here. So we're going to substitute the x into that expression. So Pn is equal to 5x minus 1. So that would be 5 times 5 minus 1, which equals 24. Okay, number 12, again, intersection is happening outside of the circle. We've got tangent line and secant line. So again, you're going to square that tangent line, square the tangent line, and equal it to the outside part of the secant line times the entire secant line. So 3x squared would be 9x to the second power. 9 plus 16 is going to give me 25. Multiply 25 and 9, and you get 225. Divide both sides by 9. Square root it. X will give you 5. We're going to stop there because that's all they asked for, was for us to solve for x. Number 14. With number 14, again, we have a secant line here and another secant line going through the circle. So at this point, you should probably pause the video because we've done all three types of intersections. So try to see if you could do this problem on your own. Okay, so with secant lines, again, you take that outside section and multiply it by the entire line. Sorry I keep clearing my throat. It's probably annoying. Apologies. We're doing 4 times 4 plus 2. And you're going to equal that to x times x plus 5. That's how you do secant lines. That's how you find the segment lengths for secant lines. So here you're going to get 4 times 6, and that's going to equal x squared plus 5x. Okay. We're going to get 24 here. 24 is equal to x squared plus 5x. Subtract 24 on both sides, so that way you have 0 is equal to x squared plus 5x minus 24. Now in this case, what you can do to solve this quadratic here is factor it. So we're looking for factors of negative 24 that when you add them, you're going to get positive 5. And that would be 8 and negative 3. 8 times negative 3 is negative 24. And 8 plus negative 3 would be positive 5. So with those factors there, I know that x is equal to negative 8 and positive 3. But of course, it would be impossible for a segment to have a negative length. So I'm sure this would be 3. Okay, number 16. We have a tangent line and a secant line. Square the tangent line and equal it to the outside segment on the secant line times the entire line. So we have x plus 5 squared. That's going to give us x squared plus 10x plus 25. And I'm just using the difference of squares. I'm sorry. The sum of squares pattern there, where a plus b squared would equal a squared plus 2ab plus b squared. Okay. Inside here we have 12 plus 15 is 27. So 12 times 27 is 324. Okay. Moving that 324 to the left side, we're going to have that 0 is equal to 25 minus 324 is negative 299. So you have x squared plus 10x minus 299 equals 0. You can use the quadratic formula, or you could factor this. It'd probably be a little difficult to find factors of 299 that would add to 10. But they do exist. So the factors are 23 and 13, negative 13. So 23 times negative 13 is negative 299. But 23 plus negative 13 is 10. So those are our factors. But again, if you did not know that those were the factors, you could just plug this into the quadratic formula. Your A is 1, your B is 10, and your C is negative 299. The quadratic formula is negative B plus or minus the square root of B squared minus 4AC all over 2A. Okay, so with that being said, I know that the answers that I have are negative 23 and positive 13. Looking at this segment here, I know negative 23 plus 5 is going to give me a negative value, so there's no way that my x could be negative, and so this is 13. Okay. They only asked you to solve for x, but I could go a little step further and say 13 plus 5. So this segment length is 18. But they only asked you to solve for x. So you're actually done right here. Okay. That is the end of the lesson. Hopefully that video was a tiny bit faster. because there has been some complaints that the videos are too long. I'm sorry.